Very quickly, I'm Josh Feingold. I'm Solutions Manager at Sawyer Software. We're the ones with the giant display out there. What I do from day to day is work at the technical level with our clients. So I am kind of the interface between our internal engineering organization and our sales organization, so I get my finger in every single pie all the time. It's a lot of fun. I get to come do things like this. So today, I'm going to be giving a talk that really you could almost think of as carrying on from Sandy's presentation. This isn't a coincidence. I've been working with Sandy on SysML 2 for quite a while now. But we're going to run through, when you see that vision of the expanding rings, that bigger and bigger Venn diagram of systems, really, from a Tom Sawyer perspective, from my perspective, it's bigger and bigger usages of data and bigger understandings of data. And this is going to be talking about the intersection of the growth of people's understanding of what they're doing with the way they need to see and interact with what they're doing. And that really is model-based engineering at its heart, and model-based systems engineering, because you are talking about the systems of systems when you're talking about organizations. So we're going to start with a brief future history of the enterprise. Now, future history is one of my favorite terms that comes from mostly science fiction, where you talk about this is the way we will see ourselves when we look back. And so we'll be presenting a brief future history, and then I'll be talking about what are the technologies that exist today for contextualizing the past, how are standards going to play in. Obviously, there are a lot of standards. Those are very much No Magic's area of expertise, and one of the big reasons why we're here. And then how are we going to use those pieces to create the future of model visualization. So let's start at the beginning, all right? Now, hopefully, most of us in this room have moved past this transition from physical documents into digital documents. And anytime you make a transition, right, this is a historical at this point, but anytime you make that transition, you're doing it for a reason, and you need to think about what are the reasons why, right? So a digital document compared to a physical document, in theory at least, faster to create. You never run out of copies, right? You don't show up at the desk and then they don't have the form you need. There's always another digital copy of something. And again, in theory, they're easier to find, right? Because you can just keep them on a drive somewhere, you have a URL to it, you have some organization, as opposed to a sheet of paper that can slide under a desk. Now, you all know that in practice that doesn't always bear out, but that is the theory. And they're faster to access, so if you know where to find it, if I know where something is in a drive, I don't have to walk down to the archives, pull out a Rolodex, figure out where everything is. So there are a lot of benefits that you see in the most fundamental transformation from just physical documents into digital documents. But that's not where we really want to go, right? A lot of people are making this transition from digital documents to databases, right? So the promise of a database rather than just a portfolio of digital documents is that you really have a single source of truth, right? The database, unless you do something rather unconventional, is not going to be able to disagree with itself on any single point of data. Again, people do unconventional things. But that's the point. And when you have something in a database, it's never lost, it's never deleted, it's there forever, and you can access it. And depending on the type of database, you may even be able to access its history. So the next transition is from a database to a data model, right? A data model is taking your schema from a database, your magic draw schema, right? Your schema for any other tools that you may have inside of your industry, and saying, well, these aren't just individual databases, each one of which has a little slice of truth in it, right? A data model says that we have a unified way of looking at these in a single context relative to one another. And now we can start doing things like checking internal consistency. Because we understand not just what the data is, but what the data means, and what it means in the broader context. Validation and verification, obviously very important. Interoperability is what you start to get as you have a single data model that's shared between multiple databases. And you can really start to create an application platform where you can say, I'm going to see my data in all sorts of different ways from a single foundation of understanding what data means, right? And when you talk about model-based engineering today and model-based systems engineering, a lot of what you're talking about is this transition from individual isolated databases into a unified data model. Right, so that's very exciting, and that's kind of well understood. But there's another step beyond that. And the step beyond that is a transition from a data model into a data process. So once you have your model, what you want to do is expose it in a way that engages your end users and allows the processes to run themselves, right? That you don't have to go in and explicitly say, oh, well, I have these library of patterns, and using my know-how as a systems engineer, or I need to start a process, or I need to go and actually buy all the parts that I'm going to use to assemble the wing of this aircraft, right? Those all become integral to the way you work with data in all of the different places that it lives, right? And we know in practice that you're never going to have a single system that does all of those things, so you can't talk about, you know, so digital thread is kind of some small piece of this, but you're not going to have a single environment that takes care of all this, right? You need to understand your entire data environment, or at least whatever subset you want to enable to work in this way, and you need to say, well, when I work with these things in these ways, that's what this means, and now you have a data process. There we go. So at each of these levels of sophistication, you have different possibilities for what you can do in terms of creating visualizations that can increase your understanding and enable you to interact in a way that really brings a lot of value to your organization. So with a physical document, right, you're going to do it manually, right? You know, I don't know if anyone has kids in grade school or remembers grade school, but you know, you may have been sent home to draw a bar chart with some crayons, right? That is the level of sophistication of data visualization that you get with your physical documents. With digital documents, you can do templates, so I'm sure that every person in this room has built far more charts in Excel than they would care to think about. But you can use that out of a digital document. If you have an individual database, you can create a siloed application that talks to the database, right? And essentially that is what each of the individual tools does, right? So Magic Draw with Teamwork Cloud has a database, and you have an application that performs that one function, and then you start adding a data model onto it, right? And you have functional applications that encompass a greater and greater degree of that systems engineering environment when you start talking to, you know, what are your queries, what are your charts, what are your analyses. And then with the data process, you get a much higher degree of sophistication. So you have a continuous integration that allows you to say, I need to interact with my data in this way, right? In this context, at this time, and these are the people who I talk to, these are the people who then receive any input that I've created in my system, right? And each of those applications can be extremely tailored to exactly suit the needs of whatever user they are inside of the process, right? And this is all achieving the goals of model-based systems engineering, right? Going further and further out the circles in that Venn diagram. So there's good news and there's bad news. So the good news is that most people are in about the same place. The bad news is that you are probably one of those most people, and that of those 5 steps that I've described, you're about, you know, step 2-ish. This is what we observe, not just in model-based systems engineering communities, not just in engineering communities, but we observe the same thing in a whole variety of places. But this is exciting, right? This means that there is all of this new frontier out there for you to explore. There is all of this richness. There are all these resources that you don't even realize yet are at your disposal. And so, who the heck is Tom Sawyer Software? Why am I up here talking about this in this context? And the answer is that 25 years ago, Tom Sawyer was a graph layout company. We would take a list of nodes and edges that somebody had inside of a graph, and we would send them back a list of geometric points where you have to place all those nodes and bend all those edges. Since then, we have kind of transformed over the last 25 years, and we provide all types of data analysis, and we provide it to all kinds of customers all around the world. We're now partnered with No Magic to help provide this, especially in the domain of SysML and surrounding standards. And the 5 major areas where we see people really struggling with exactly the same problem that you guys are going through today is in network topology, right? So IT infrastructure, link analysis, defense and intelligence type of applications, detecting leaks, detecting fraud, schematics and maps, so understanding geospatial data that is also connected data, right? Very, very complex problems, right? Logistics has very strong dependencies on understanding both the topology of a network and the geography of a network. And obviously there are all kinds of logistical supply chain problems that impact the creation of advanced systems. Architectures and modeling, so really that's what we're doing in here today. That's the bread and butter for No Magic. And then processes, flows, and dependencies, right? So both business processes, but also other types of processes and industrial processes. So as I said, we do this for all kinds of different companies, so everyone from the US government to tiny 2-person startups, everyone from finance to IT to engineering. Many of our customers you'll actually see in this room already, but we get around. So the good news is that you're at the fun part, because you probably, assuming that you are at about this step 2 where you're transitioning from a collection of digital documents into some isolated databases and starting to understand your data model, we're actually really good at helping people get through this problem. And this is well-trod territory because the scale of data is starting to demand it, right? And this is really a scale problem. Other industries have hit this scale of data before you, so you get to ride the wave, right? You get to surf down, you get to go down the water slide. I like the rainbow water slide. I don't know about you, that's my favorite. So in order to do that, you need to leverage data standards, right? And there are real data standards, right? Things that are formally standardized. So the fun little green guy up there is the Apache Gremlin, who represents a property graph query language. Obviously there's REST protocols and REST interfaces, there's JSON, there's XML, there's SQL, there's RDF, right, and OSLC that goes along with it. And then there are things that are effectively data standards. They're so common that you might almost call them that. So Cypher out of Neo4j, and you have also providers that actually give you those data standards. Right, so obviously No Magic gives you a REST service. It gives you OSLC, which is RDF. You have big data companies like Amazon and Oracle that are giving you RDF as well as Gremlin interfaces. And then you have things that aren't exactly standards, but they might as well be like Excel. So there is no standard that has ever been written that explains what Excel does and why, but we sure as heck use it. So, you want to go from these are the data standards to these are the modeling standards, and making those talk together, right? And that was a very big emphasis of what Sandy was talking about in terms of interoperability in SysML, right? And SysML SysML 1x is something that we've been learning about what it does well and what it doesn't do so well for the past decade. In SysML 2, we're going to try to bring those forward, those strengths, and kind of shore up some of the weaknesses so that we can work in exactly this type of environment where you're bringing the whole organization value instead of just one particular project, one particular aspect of one project. So you really want to leverage standards not just for SysML, but also ontology standards. Like 5.0 is a good example where there's the financial industry business ontology that you've probably seen Bobbin wandering around here that she's worked on extensively, that lets you talk about, create these data models that do allow you to unify these multiple isolated silos. And so let's remember why we wanted to transition from database to data model, right? We want consistency, we want interoperability, we want V&V, right? We want to be able to create an application platform that says, I have 5 different business units, every one of those business units has 15 different legacy systems, but I know they're all trying to tell me the same thing. And now I want you to help me understand what that thing is that they're trying to tell me and apply the same solution in all of those spaces. And so how do you do that, right? So you have to build a perspective. In this room, I get to use the words view and viewpoint, which is great. It's not something in a lot of rooms people will actually understand. This is not something that's really been dwelled upon to a great degree inside of the systems engineering community, what exactly really is a view and a viewpoint. But the terminology, right, basically means that you have someone who needs to see a view to do their job, and this is the actual view that it creates, right? That's a view and a viewpoint. Which if we look at the diagram up here, right, you have your enterprise data sources, that's what you have now, right, to a greater or lesser degree. Some combination of Teamwork Cloud, Magic Draw, databases, Excel sheets, right, all kind of fall under that. What you want is a set of interactive views that lets you, in the context of your user, you meaning both you as the engineer and you as the end consumer of model data, do stuff, learn from it, interact with it, right? And so what do you need to connect those 2 dots? Well, first you need to have your actual data model. You need to understand how the data federates together. Then you can create processes that run against that data, allowing you to perform analytics, to do model transformations, model queries, all the stuff that you need to then transform it into this set of interactive views. And this notion of creating an executable view and viewpoint engine, configurable view and viewpoint engine, is actually what Tom Sawyer Perspectives has been doing for more than a decade now. I think 12 years was what we call Tom Sawyer Perspectives. And so that is really kind of where we came into this game, and only in about the last 3 years have we discovered that systems engineering was coming to these same conclusions from a different angle, right? Because their needs were different. And so the only part of this where I'm even going to talk about our products really is that we do have this technology. We have a visual designer that allows you to configure views and viewpoints, that allows you to say, these are the types of data sources that I want, this is the way I want them to look, this is the collection of views that are going to be informative for a particular user. Oh, I'm going to tailor this one for ed and HR, and this one for admin and accounting, right? And the types of applications that we often see are that people want to connect to graph databases and see graph databases unified with their legacy systems, right? Either, or even in some cases with their modern systems that are more tailored, right? So you've got a graph database that represents live running data, and you have an architecture that's defined in SysML. You've got model-based engineering, right? This is a big growth area as people are coming up the learning curve. Just like most people in this room are increasing their usage and understanding that as models get big, as they reach scale, you need more automation. Business processes. So there are all kinds of things that you can do with a business process, but one of the best things you can do is never let anyone look at it. And I'm going to talk about that in just a second. And then, of course, you can have tailored applications. Right, so it's not just about using Tom Sawyer Perspectives and Magic Draw, right? This is a rich environment. There are all kinds of very powerful, very good tools that have been built to do specific things, And you want to keep leveraging that even as you move to a unified data process, right? So I have a screenshot from Perspectives up here, but I've also got screenshots from Magic Draw, 3D CAD, as well as the view editor in OpenMBE, which is very cool. You should all go check that out too. So what we have now, this image here combining the parts, it's not giving us quite enough credit. We don't have just all the blocks on the floor. We've built a few towers, but now it's time to put the castle together. And so what you really want is to use this approach to create a continuous integrated data model throughout your entire organization, throughout the entire process that supports your engineering efforts, and even your non-engineering efforts. And at key points, you want to have the right type of application to expose all of that data, right? And so I'm going to go through a non-engineering example to give you the context of how all of these pieces fit together, because I think you can all imagine all the engineering examples. But this is a very, very simple process. It's not meant to be, exhaustive or highly detailed, but it's just meant to show that this is the type of work environment that you can create when model-based engineering goes beyond the scope of what it envisions itself to be today. So let's say I want to hire somebody, and I do want to hire somebody, actually. Anybody who's a good Java applications engineer and is looking for a job. Send them my way. We're very busy. So let's say that I want to hire somebody, and the way I'm going to do that is I have an organization chart that represents my live organization, right? It shows me who are the people, what departments do they work in, who do they work for, what are their job titles, what are those job descriptions. And I'm going to go in and I'm going to add a new individual, just a job title, unnamed, and I'm going to put them in an office somewhere in the world. And then I'm going to go into some sort of editor and it's going to say, hey, you just added somebody. Well, why don't you go tell me what that person is supposed to do? And maybe it's going to pull out an existing job description if I used an old title. Maybe it's going to let me create a new job description if it's a new job title. But I've started a process and I don't know it. Right? I've started the process of hiring someone, but I haven't gone in and created a new business process instance explicitly, because why would I do that? It doesn't sound fun. And then someone's got to approve that. Probably a few people have to approve that in practice. So they're going to need to interact in this space where I actually define the job description, but then they're going to need a form that says, yeah, all right, this sounds good to me. And then either we're going to decide to go ahead with the hiring process, and I'm assuming that we will here, or we're going to say, okay, we're just going to kick out. And now, what that's going to do is, in an automated way in the back end, it's going to say, I've done all the things that need to be done so that I can actually post a job description to the website. So let's just go ahead and post a job description to the website. Now we're going to start collecting resumes. Then I'm going to screen those resumes, and I'm going to talk to people. And I'm going to do most of this work manually outside of the context of a particular application. And then, once I've hired someone, I get to update the name inside of my org chart, and the organization now knows, oh, there's actually a new person in this tree, and this job description is now filled, and we can go back and we can close the job description on the website and do all those fun things. But at the same time, I need to add this person to our IT infrastructure. So someone has gone in an enterprise architecture setting, and they have defined what is the new hardware, what is the software configuration for that person's job role, right? Does this person need Magic Draw? Do they need Microsoft Office? Do they need IntelliJ? Do they need, any of the specialized tools that are going to have to happen? And you need to describe that with an enterprise architecture so that you can actually do the job consistently. And then after you say, okay, well, I'm going to do that, now you get to look at the live network with another visual application and say, here we are, having implemented against a particular architecture at the same time as we're doing the hiring process to actually bring this person into the organization, right? And all of this happens without anyone being aware that they are executing a business process, but that's exactly what they're doing. It's all happening invisibly on the back end. And then you're done. And so this is step one, actually. And step two is that it turns out that you're already doing all of this today, aren't you? when you hire someone, you actually do a bunch of stuff. And you probably don't look at a business process. And you probably do a whole bunch of manual steps that someone in HR has to remind you how to do every single time you do it, right? But you actually do the same thing. And so this business process is implicit in the way you work with your data model, right? And so if you're really doing this right, if you've really got your data process down to an art, you can extract this whole process from what you're already doing. And so you can validate that what you are doing is what you're supposed to be doing, and you can expose the internal logic of your business and document it in a way that, for example, if you need to demonstrate to the FAA that you have put together your airplane the way it's supposed to be put together using all the validation and process steps that are required, that you've actually done so, right? And so that's it for the slide deck. So I imagine that there will be some questions here, but we have 2 demo theater sessions today where you can actually get kind of a live demonstration of the state of technology. And what I've given you is actually a bit of a future roadmap. So pieces of it exist today, pieces of it are brewing. We're a platinum sponsor. We've got the great big booth out in the hallway where you can talk with me at any level of detail you like, as well as our other representatives at the booth. If you drop your card in the fishbowl out there, well, we can, maybe give you a Starbucks gift card, or somebody's going to win the drawing, right? So I encourage you to stop on by and ask questions. That's it. That's me.